die with the disease. Life remains very much terrible, very much painful. One of the most famous personality or supermans the world has ever seen was Christopher Reeve. While performing stunt on one shoot, he suffered a major cervical accident. Spot he was paralyzed, quadriplegic. Big desire to live. He wanted to come back as a Superman again on the stage. His drive towards researching, find out what can make him walk again. He started researching on stem cells. It took years for him. He always desired hope and dreams for the stem cells. We live in a time where the word impossible and insoluble are no longer part of scientific community's vocabulary. Each day we move closer to trials that will not just minimize the symptoms of disease and injuries but eliminate them. Unfortunately, he died in 2005. Before he could see the dawn of coming in stem cells for therapeutic applications. But nevertheless, he introduced the stem cell research legacy to the world application to make doctors to understand, yes, you can do it. As speakers before me already have spoken here about the embryonic stem cells, the wonderful part of the embryonic stem cells is that they are viviparent. The power of the cell is so strong. All 30,000 genes which are present in the cell are open here. They can develop all 220 types of cells in your body. No organ is left behind, which they can make it. Only social ethical issues were the major issues, because of which they had a lot of objections to come in. Here you can listen to President Obama, what he says about the purpose showing this video for you is that the most researchful country in the world is US. The entire research of stem cells is happening in US. The country where maximum research is happening, there was a ban on embryonic stem cell research. The entire world would have lost the future of stem cells if Obama would have not lifted this ban. The two issues more important which were discussed then was one, destroying the life of embryo to treat was a major issue which was pointed out. The question was, a baby is viable. At what stage we can say this? Life is there. There are believers who could say when the blood circulation establishes, the baby is viable, life is viable. There are people who used to say when the embryo is formed, itself is a opportunity life has been given to it. But mostly it is accepted when the blood circulation is established. And second, which has given a relief, is that most of the IVF centers, after fertilization, remaining embryos which they discard, those could be utilized for research purpose. Looking at all the problems which were faced by embryonic stem cells, the science went ahead. It took Dr. Yamanaka, a surgeon, spine surgeon from Japan, 10 years for him to solve the problem which were faced by embryonic cells, which could develop almost all tissues, cells for therapeutic purpose. He was a person in 2012 to give a world's best gift of cellular therapy induced pluripotent concept which ruled out all ethical issues, all social issues, all allogenic tissue issues, because induced pluripotent cells is autologous. It does mean he took a somatic adult cell from a skin, induced this cell with 4 major transcription factors of all 24 existing transcription factors: OCT4, SUX2, KLF4, and CMAC. To his wonder, he could find this adult age cell turned to embryonic character. This was the time the world could see the reversal of aging cycle of a human being could be done. An adult cell going back to the embryonic character. If that was possible, you could imagine a man can live ageless. This is a wonderful, massive full cell which can be differentiated into 220 types of different cells. This was a time when everything people felt is a fiction. It cannot happen. It cannot happen. It's not a fiction science. It's a stem cell research led to never before in the history of medical science such a gift received to humans. Stem cell which can regenerate cells of 220 types, made them into different kind of tissues, and thereby you can produce the organs. The most wonderful part of the theory is how you could use simple cells in a petri dish, grow in a lab, inject them back to the body. Simple concept of application of induced pluripotent cells for routine therapeutic purpose. But when I told you the concept of organ formation from a tissue, from a cell, in 1960s, I'll tell a small story before I go to the organ shop. In 1960s, Dustin and Hoffman released a movie where the plastic revolution started, got the first plastic revolution, where everything scaffold structured using plastic. You can see the glass, table, pane, whatnot. Even aeroplanes, bodies of every vehicle were made of plastics. It's a scaffold over which rest of the tissues or rest of the structures were built up, and that particular machine or particular instrument was made. The idea came to some of the most intelligent people in the world. Could we make some kind of biodegradable scaffolds? Yes, it came in existence. These biodegradable scaffolds are wonderful things. I would say Dr. Atala Anthony from Wake Forest Regenerative Medicine Center, pioneering in the work of scaffold work. He could develop these scaffolds which could make almost every organ of the body using induced pluripotent cells, a specific medium, organ specific or tissue specific or cell specific mediums which can induce or which can use signals to cell to differentiate into specific organ cells. I would rather take you a lab of organ shop where you could see organ transplant of human-made developed lab transplant of bladder has already been done. This is a 3D printing technology. A sheet of scaffold on which the cells are impregnated. Put this into a small incubator where 37 by 5, you can say 5% of CO2 and 37 degree temperature, the organ develops in the scaffold. The prototype kidney which he could develop in his lab, it took 7 hours. The only problem was how to develop vasculature, which he could develop the vasculatures also. The bone being regenerated. one technology which is just come up with a scanning technology, where a big wound of the hand or the body could be scanned under a scanner, and the scanner will spray. It will immediately calculate the depth tissue required, what type of tissue required, and the scanner will print out, spray those kind of cells on the tissue, damaged tissue, and you can walk out without any hospitalization or without any anesthesia. The last which you could see was the formation of bone in the laboratory. I think this was a wonderful tissue organ shop where you could go anytime and find out what you are suffering from. And hence, no more shortage of organs, no more rejections, and no more waiting list for any kind of organ transplant. These are the different organs which were developed in the future dishes of laboratory. The technology which I told used in this kind of organ development were 3D printing technology. Now they have brought one more technology, the 4D technology. The 4D represents the computer software given to the printer which can decide itself to give the shape to the scaffold. This is the 4D technology just come up. Then scanner technology which I show you, the scattered organs like liver and kidney by washing out cellular materials. This is one more process is developed where the organs from a cadavers like liver could be removed. They could be washed in a washing machine, remove the complete cellular component. What remains is a structural component which you could keep this shaped component or scaffold in a cryopreservation, and whenever you want to have a transplant to any specific person, take the tissue of that person, produce the induced pluripotent cell, culture them, differentiate them, tissue-specific stem cells, which are very important to cover up the organ, and the organ could develop in 3 weeks' time. You can develop an artificial, synthetic, man-made liver using scaffold. So ultimately, the man-made machine, man-made organ shop, you could see how it could be utilized using generative medicine. You can use the grass, you can use the plain scaffolds like you can use particularly vessels, artificial vessels, or urethras, you can make out of it like, and using cells, you can make the organs, biopsying and repair of the damaged tissue with the help of cells and scaffold. So this is your shop, where whenever you want, you can go, book yourself, register yourself, and take your organ. The biotechnology related to regenerative medicine doesn't stop here. Many of our colleagues were asking some questions. Instead of taking stem cells from outside, put the tissue-specific stem cells which are in our body, why could not be they activated or stimulated? Yes, my dear friends, that's always possible. We all know signaling system and differentiating systems are working on micromolecules or protein molecules like chemokines, cytokines, growth factors, which play a major role in differentiating these tissue-specific stem cells. If we get to know there are specific markers which can be utilized, those markers could be activated using specific ILs or growth factors or tumor necrosis factors. All those, one of them could be utilized here to activate them and induce those induced pluripotent cells, induce those endogenic stem cells in your body. This is not a story, this is also one of the science in cellular medicine where people are using this as a therapeutic purpose. These we can utilize in the form of cytokines and chemokines. If I can show you the next slide where I have already mentioned that cytokines as a micromedicines can be utilized. These cells, when induced pluripotent cells in future will be dispensed from a pharmacy also when you can prepare these stem cells in a petri dishes or kits. Specific specialization like myocytes, cardiocytes, chondrocytes, kits will be available in future, which you can utilize for your therapeutic purpose. Whenever you have any problem specific to those organs, you can utilize those cells and take the treatment as you want. How does it work? A small slide which wanted to show you this, how the stem cells are harvested, they are utilized in the lab, and how they can be utilized for organ preparation. Whenever the purpose of saying me the other sciences of medicine development was more important for one reason. When you utilize cellular medicine with robotics, with genomics, or even proteomics, they will become a healing force for treating incurable conditions. Advances in other cellular stem cells, which is not stopped where we are today. In future, which I look in another 10 years to come in for you, the greatest theory will come of VSCL cells, very small embryonic-like stem cells. Now, this detection of these cells in the body in therapeutic application is going to make a very big revolution against cellular medicine. The reason being that VSCL cells are autologous, they are present in your body, they respond to the stress, they respond to the injury, they belong to the lineage of progenitor cells, progenitic cells, that is gonadal tissues. During developmental, they differentiate into different, they are mobilized into different organs as well in the bone marrow. They play a major role to maintain tissue homeostasis today in your body. But they are so small, they are isolated presently, but in the lab they are still to be multiplied in millions and millions. NewStem is a company in US who has been licensed for clinical trials on this. We have a special meeting, we had a special talk with these people to bring this cell isolation technology to India. Hope so in the 2 years we will be at StemRx getting this license to isolate the cells in India. If this happens, you can have an ageless life because these are embryonic in character. They belong to your own body. They are existing in your body. Only what requires to you to multiply them in millions and millions and re-inject in your body. If you could get this achievement, every corner you can have a lab where you can go in, donate the blood, separate the cells, multiply, infuse in your body, your age will reduce automatically because they are pluripotent.
This is an educational CME which is indicated to educate the most of the lay as well as collegiate population from medical literature to understand the newer coming technologies in medicine. What is going to happen in the next 100 years in medicine? How it is going to change the human life? One of the most researchful subjects which we are going to talk today is cellular medicine, that is stem cell and its therapeutics. How it is going to change the human life for all those conditions where the proven therapies have failed to treat the patients. This is one of the cutting-edge technology which we would like to pass on the knowledge to all medical fraternity and adopt this new technology for the therapeutic purpose. Yeah, there are many myths and facts about this technology amongst the laymen as well as in medical profession. We are looking to remove those myths and teach them real facts of this technology, how it is going to treat these incurable conditions which we could not do by traditionally proven therapies. So there is a big need. Otherwise, the patients who suffer and die with those conditions, you can say the conditions like thalassemia, conditions like rheumatoid disease, ankylosing spondylitis, there are a number of diabetes type 1 where there is no treatment available. StemRx has taken a lot of efforts last 4 years in research doing and brought out so many successful protocols from autologous therapies from their own cells to treat n number of more than around, I would say, rather 80 different conditions which be treated today. Yeah, the best message you would like to pass on to the community is that we no more can say no to the patient, we can treat them by all other conditions. You're welcome. Thank you.
Yeah, I'm Dr. Anand. So I'm the director of Autostem Laboratories, Chennai. So we are working on stem cell research and yeah, I'm Dr. Anand. I'm from Chennai. So I'm the director of Autostem Laboratories. We work on stem cell research. We are also working on therapy aspects as well. So we are working with the autologous stem cells. Our primary aim is to develop a foolproof technology related to stem cells for better cure and for those that are actually right now is not able to be cured. So this is what we are aiming at. So we principally go for bone marrow derived stem cells as well as adipose derived stem cells for getting the culturing the stem cells for the therapy. Yeah, of course, Dr. Mahajan is a pioneer in this field, and he has been instrumental in several very good results in the using stem cells. So, besides certain catalytic peoples are required to upgrade this field of medicine, which is coming up and is in the nascent stage at present, so which will of course develop from this area, because it's a feature of medicine basically. Naturally, because there are so many doctors who doesn't know how to start with, and basically. And second thing, the ICMR itself has several regulations coming up step by step, and every year they are actually pushing it up. So in fact, they have approved certain therapies and not under the clinical trial, of course, right now. So that is those that is in the blood-related disorders and others, they are right now approved. So it's in fact coming up in a very big way. Thank you.
Today we are organizing this rather. अच्छा, we are organized. Okay. Past tense मध्ये पाहिजे सगळं. चल कसमा खाली पाहिजे. Today we have organized this particular seminar to develop awareness among the doctor community and the patients. This is an upcoming event and the method, or rather you can say technology, where it is possible to treat uncurable conditions which are not treated by traditional medicine. So there are a lot of opportunities for the doctors and to give a quality of life to the patients. So stem cells and regenerative medicine is the upcoming field in medicine, and it is going to revolutionize the medical field. Yes, of course, it is a need of an hour, because this is a new subject, new technology, and it is not known to many people. Those stem cells are there in your body, but many